Okay. But we were discussing about networks last day, right? Before the examination, we were just discussing about networks, and we were learning about what is a network, why networks are created, and how networks can be used, right? These things we have discussed. Okay, computer network. Computer network is basically two or more interconnected or connected computers, two or more connected or interconnected computers, which works together. Right? These computers are working together for the purpose of communication and resource sharing that can be connected using wired or wireless media. Okay, so two usages of computer networks. What are they? Usage number one of computer is, yes, what is the usage number one of computer? It is resource sharing. Usage number two is communication. Resource sharing means it can share any resource. It can share file, printer, it can share internet, it can even share settings, user documents, it can share processors, application or software, components, peripherals, printers, scanners, like things can be shared. So anyway, whatever resource. So one reason is resource sharing. The second reason is communication. It can communicate, pass messages, have a chat, maybe voice-based communication, video-based communication, whatever. So communication and resource sharing, those are the two usages of computers. We have learned about that. Then actually all these things are related to that, ability to access internet, basically internet sharing, resource sharing, share software, hardware, resource sharing, easy to take backups. These are also resource sharing. Then important works to the network, storage sharing, software sharing. Then common document photos sharing again. Email, short message services. This is communication and resource sharing. Those are the two purposes of the networks. Then we learn about the type of wired connection, wireless connection. So can you give me examples for wired connection? So what are the wired methods of connecting? Guided or wired media. So can you name a few guided wired media that we have used for the communication? Guided media or wired media. Hello? Lakshya, tell me one guided media. Nadun. RJ45 is the port, right? Nadun. RJ45 can be port. Like a media port that you are using to connect is RJ45, but that is not the media. Lakshya, can you hear me?
Yes, sir.
Okay, then I need your answer. Please talk when you can hear you. When you can hear me, please talk. That is a good practice. I think you know that, right? Okay, tell me guided media. Guided or wired media that you can use for the communication. So we learn these things.
So optical fibers.
Yes, fiber optics. Very good. One answer is fiber optics. Rovinu, can you tell me another answer? RJ45 is connected. This is RJ45 is connected to which cable? What is this cable today? I'm asking about the cable name. Rovinu, can you hear me? Rovinu.
Yes, sir.
Okay. So then, can you tell me what is the wire name of this? So this is the RJ45 connector, but the wire connected is called. The connected wire is called twisted pair, right? The connected wire is called twisted pair. This is RJ45. This is not R, so, but we can call that RJ45 cable. But the main name is twisted pair cable. Name of this is fiber optic cable. There's another one. I explained that in the note itself, but it is missing here. You can add it to these slides because like it was there in the note. That is coaxial cable. Coaxial cable. Right? Coaxial cable is one thing that you can use to connect coaxial cable. So we discussed about that coaxial cables are used in so this CCTV wiring, right? Closed circuit television, CCTV wiring to connect the DVR coaxial cables are used. DVR connection, CCTV. So we are using basically coaxial cables. Here, can you see? This is a coaxial cable wiring. These are called BNC connectors, right? Coaxial cable, and here BNC connectors, coaxial cables. These are used here. This is also something similar. This is not. This is actually VG. This is AV cable, audio video cable. This is not a coaxial. Coaxial. So coaxial cable is this. Can I see a coaxial there? Yeah, here you can see the orange color one is coaxial, right? Orange color one is a coaxial cable. And this is the real image. You can see how it looks like. So this is there in the antenna cables, coaxial antenna cable. Right, in antenna cables also this coaxial cables are used in antenna cables. That is another wired media that you can see. Okay, so what are the wireless media then? So these are guided. Wired media are also called guided media. Another name is guided media. Wired media or guided media. Yes. Anything else? So wireless media. Can you tell me wireless media? Yes, can you tell me wireless media?
Bluetooth.
Bluetooth. What else?
Wi-Fi.
Wi-Fi. Okay, correct. Bluetooth is correct. Wi-Fi is correct. Anything else? Bluetooth, Wi-Fi, anything else? Yes. Bluetooth correct. Wi-Fi correct. What else? Yes. What else? Bluetooth correct. Wi-Fi correct. That's all. I got few answers in chat also. Let's see. GPS, radio signal correct. GPS is called global positioning system. That is not a signal type. Wi-Fi, Bluetooth are correct. Right. One more thing. So what about the remote controllers? Remote controllers, what is the signal use? Yes. Remote controllers. What is the signal using remote controls? That is called infrared. Infrared signal. Adorakta kirana, infrared. So that is also correct. Actually, so Bluetooth, there's another one, Zigbee. This is missing here. Zigbee is another one. Bluetooth is a technology, Zigbee is a technology, Wi-Fi is a technology, but all these are radio waves, right? These are not different waves. These all are Let me use another color. It's not clear. All these are radio waves. Bluetooth, Wi-Fi, Zigbee, all are categorized under radio waves. The specialty of radio waves, radio waves travel omnidirectionally. Hammer direction it is globally spreading. It travels omnidirectionally. It travels omnidirectionally, so spread to everywhere. It travels omnidirectional, so it spreads to everywhere. That is the nature of radio signal. Right? Bluetooth, Zigbee, wave, Wi-Fi, all are. Actually, Bluetooth is a short distance, very short distance, like 10 meters. Zigbee is also 10 meters, similarly. Wi-Fi, it travels 50 to 100 meters, some more range, but in meters. Radio waves like UHF, VHF, these are radio waves, ultra high frequencies, very high frequencies. These signals travel long distance. It can travel even kilometers away. And one more thing which is missing here, which is used for the satellite communication, is you can say microwave signals. That is also a type of signal, but that is not a radio wave. Microwave. So that is unidirectional, right? Infrared is also unidirectional. I'm just summarizing, right? Because we have learned this already. Unidirectional again, right? Microwave is also unidirectional, right? It's only also travels one direction. Unidirectional. Microwave travel unidirectional, and infrared is also traveling unidirectional. Only one direction. But these are omnidirectional radio directions. Omnidirectional. So please indicate that if I have not given in the note, but I hope I have given this. So what are the type of signals? Wireless media. Infrared is a light, but we cannot see that light. Especially dogs, like animals, can see that light, not us. Then Bluetooth, actually that is also a radio signal. Radio signals we can't see. Wi-Fi, Zigbee and all, cannot see that. Okay, let me know once you updated. I can proceed. Okay, I hope it's enough. UHF means ultra high frequencies. VHF means very high frequencies, right? So UHF is basically fast, ultra high frequencies. VHF, very high frequencies. HF is high frequencies. Okay. So let's see. Okay, then actually we need to move and understand the devices. Right? So what are the devices that we are going to use that we need to know? So what are the devices? So devices can be, okay, let's start writing this. I think we can start from here. So please write the heading. So we already learned actually in this note, we already learned this part, we learn about the devices, what we need to build a network, right? What is needed for the creating this network, basically two computers, computing devices. Then you need wired or wireless media and network interface, and also software and protocols. That is what we need to build a software and not network. So, but we didn't discuss about the tools and software that we can use after the network. Actually, we can use these devices to enhance the network. So let's write down network devices. So number one is NIC. It is network interface card. So why we are using network interface card? It is the end user. It is providing the end user connection. Right? End user means the final end. NIC provides, please write down under that, end user connection. Either using wired or wireless mechanism. Each and every computer or computing device which is connected to a network will use a network interface. It can be there in the motherboard itself, and then it is called onboard. If onboard interface is not there, we need to install or plug external network card. It is possible to connect more than one interface. It is possible to connect more than one interface using a single device. So single device can be connected to multiple networks or multiple network ports or multiple network connections using more than one interface. So especially servers do this, especially servers means service providing computer do this, that is network interface card. Please write down this and please let me know once you are done. Otherwise, I will be waiting infinitely. Okay. So network switch is the next thing. So network switch is basically used to connect. So there are some, in the network, there are arrangements. These arrangements are called topologies. Right? These arrangements are called topologies. So network switch is used to connect computers and computing devices in centralized star topology, networks, and tree topology networks. Centralized star topology networks and tree topology networks. So what are these topologies? Topologies means like here topology means arrangement of the network. So if it is arranged like a star, we call star topology. If it is arranged like tree, we call tree topology. Okay, let's draw these two topologies to understand. So you can see here in this image, the star topology basically connecting. This can be a switch or hub. I'll explain the difference, right? So what is switch? What is hub? I'll explain the difference. What is a switch? What is a hub? I'll explain the difference, right? So these are the nodes are computers and computing devices. Can be servers, service providing computer, or it can be clients, service consuming computers. Anyway, all these are connected to the centralized device. The centralized device is switch. Here, another one. This is tree topology. You can see there is a common backbone cable. This is like a fiber cable in internet. Internet has a common fiber optic backbone like this. To backbone cables using T-junctions, these are called T-junctions. Using backbone cables, these T-junctions are connected to switches or some devices. Here server is connected, here switch is connected, here switch is connected, here another switch is connected. So likewise to T-junctions, to this shared backbone, this is what the tree topology is. In tree topology, there is a shared backbone. This is like the stem or the trunk. To the stem, branches are connected. So the branches, to the branches, sub-branches are connected. These are the computers or the computing device. We call nodes. So here also switches are used. This place, and this, we can say tree switches. This is another topology that you can use. You can roughly draw this. Yeah, I'm not going to give you this node, because you need to remember this, otherwise you are not talking and you are not remembering the stuff. So therefore, I need you to draw this. Please draw this quickly. Quickly draw this. Okay, and the next is, so what is this network hub? Right, I have mentioned here also the switch and hub, like both can be used. So when connecting the devices, switch, hub, both can be used. But what is hub? Hub is basically, hub is with all device. So please write down network hub. Hub is all device used instead of switch. When a message is sent to hub, it will broadcast the message. It will broadcast the message. When a message is sent to hub, it will broadcast the message to all the connected devices. Send it to all the devices, regardless of to whom you have sent the messages, regardless of to whom you need to send the message, send it to every device, everywhere. When a message is sent to when a message is sent, hub will broadcast the message to all the connected devices. Therefore, the traffic of a hub is more than a switch. It will slow down the hub and make it less secure and less intelligent. That is the nature, because it is sending to everyone now. So therefore, it will slow down, right? It will slow down the hub, and it will like this is unnecessary overhead, less traffic, less secure, because everyone can obtain the message. So it is less secure. It's not good to send messages, because specific messages, because others can also get the message. Only the intended, like when the message is broadcasted, this is also important, by the hub, receiver will check and get that if it is addressed to that receiver. It will become receiver's responsibility, right? Not the hub's responsibility, but the receiver's responsibility. But switch, in the other hand, switch can unicast. Unicast means basically sending to a specific person. Then it can broadcast, multicast. Multicast means sending to multiple parties. Or broadcast, sending to all, based on the requirement. So switch can do that task. Hub, switch, and the router. Finally, the route, not finally actually, so we need to discuss more. We need to discuss about client server environment too. But before that, I think we better discuss about, you can see three images, see, hub, switch, and router. Actually, so don't think that if you see this antennas, it is a router. Switch can also get antennas, and hub can also get antennas, right? So there are hubs with antennas and switches with hub antennas. The antenna එක switch hub තියෙනවා. ඒක පටලවා ගන්න එපා. There are switches and hubs with antennas. Therefore, don't confuse. Antennas are there for Wi-Fi connection, wireless connection. Hub with antenna. It is there, right? So don't confuse. There are hubs with antenna and switch with antenna. Switch with an antenna. So that is also there. Network switches, network switch, right? Basically network switch with antenna. So in the network switch, antenna can be there. In a network hub, antenna can be there. In a network router, mostly in the router, you can see antenna. The reason is routers are providing both Wi-Fi and wired connections. That is typically it's providing both. But hub and switch, when you are buying, you have to check whether it has the Wi-Fi ability. The difference between this router is basically, please write, router can find the best and fastest route or path when a network traffic is sent from one network to another network. It is basically connecting two different types of networks. It's basically connecting two different types of networks. It is acting similar to a traffic police. It is acting similar to a traffic police. by handling the network traffic. By handling the network traffic, actually. So traffic policy is not driving, traffic policy is in the junction. Similar, acting similar like traffic police. So basically he's guiding, he's telling here to go, where to go, turn left, turn right, likewise it's guiding. And it's guiding you to connect to the specific path, right? That is what done by the router. Earlier days, actually, we didn't use routers. Instead of that, we use modems, but our ISPs use routers. But now, actually, because of the high traffic at the home environment also, we need to use routers. But typically, the main device used was modem. Modem is called modulator, demodulator. Okay, the fourth and fifth is modem. Meaning is modulator, demodulator. This will convert analog signals to digital signals and vice versa. Vice versa means the reverse, right? And vice versa. Analog signal to digital signals and vice versa. Existing telephone networks use analog signals to transmit data, and computers use digital signals. Computers use digital signals. Therefore, we need this basic conversion. Routers were there in the market. In earlier days, but now it is integrated with router switches, not the routers, sorry, modems, right? Yeah, modems. Modems is modems are there in the market. Earlier days, like you could have buy a modem. So when you go to the ISP will ask you two questions: do you need a router or modem? So they are also telling router is expensive, modem is cheap. Therefore, people used to select modems, but that is not a very good selection, because modem can only do the conversion part, digital to analog, analog to digital. Any device need that, but router has both features. Router can modulate, demodulate, as well as it can route. So it has more features. Now, actually, modems are not in the market. Modems are very like cheap devices, but those are not in the market. Instead of that, now we can find the routers. Inside the mobile devices also, the modem facilities there. In your mobile phone, the modem facility is there, because we need to modulate, demodulate. In the mobile phone, you are using digital signals, but when transmitting, you are using analog signals. Okay, quickly get this part done. Up to now, what we have discussed, let me summarize. So we just discussed about the media. We couldn't discuss about the server. I'll do that next day. Right, I'll make sure that can be done next day. And the next thing is, when you are connecting this, you can see this is a centralized network. Okay, sorry, here you can see. server is connected to the switch and switch is connected to the computers by, this is a centralized device, and you can see the devices are connected to this, and through that the network is created, right? Actually, if you need to connect this to a external network, you need to connect this switch. So you can draw this part as well. You need to connect this switch to a router. Router is basically capable of finding the best route in the internet. Here you can see this is internet cloud. You can just flow as a cloud. My cloud is not very good one. You can just write internet there. Internet. Actually, inside the square, what you can see is a network. But when you connect to a public network, it will also become part of the internet. So this public network, and this is a private, this is public part. You don't know where to go. This is your private. And so for those who are coming from the outside public world, router will help to find the exact location. And those who are going from the private world to the public world, again, the router will help finding the location. That is the beauty of router. Actually, this switch can be replaced using a hub, and even the wireless devices can be connected using Wi-Fi. And this is how a typical network is there. But in your home network, you might not have the switch, because router also can directly connect these computers without connecting to the switch. You can connect computers to router as well. That is alternative mechanism. Then the switch will not be there. But that is not a very good network, because it can only give like limited amount of connections. But if you need to expand the network, a switch is needed. Okay, so with that, I'll stop this part. This is a bit technical. So if you cannot understand, please let me know. I'll explain this again in the next day. Good night. See you all next week.